Are pleased to welcome you today to Mission Innovation's Think Tank webinar, The Circular Carbon Economy from Concept to Realisation. The objective of today's event is to share knowledge and perspectives on the circular carbon economy, a concept that builds upon the principles of the circular economy and applies them to managing carbon emissions. To reduce emissions, reuse carbon as an input for feedstocks and clean fuels, recycle carbon through the natural carbon cycle with bioenergy, and unique to the circular carbon economy, remove carbon and store it. Realising a circular carbon economy will require significant efforts to bring down the costs of key technologies. This is exactly the role that Mission Innovation and our member governments can help to play. Mission Innovation is a global initiative catalysing action and investment in research, development and demonstration to make clean energy affordable, attractive and accessible for all. Our member governments are collaborating to pioneer the critical clean energy innovations to accelerate progress towards the Paris Agreement goals and pathways to net zero emissions. So, today's event is being delivered through the Mission Innovation Think Tank, which is a critical component of our general portfolio. The Think Tank is a new MI initiative which was only launched in 2023 and is focused on convening knowledge sharing activities and events just like this one that have cross-cutting relevance across MI's work. So the circular carbon economy is one such cross-cutting topic. As our MI member governments advance collaboration to scale up our relevant technologies, from carbon management to clean fuels, the circular carbon economy can provide a useful framework to guide action and investment. We hope that the think tank will foster more knowledge exchange on this topic and others in the months ahead to help MI members learn from each other in addressing common challenges, strengthen MI's collaboration with global partners, and increase our visibility and outreach by disseminating this knowledge into the broader clean energy community. So as I mentioned, today's event will be recorded and that will be available after the meeting, and also following the event will be a written think tank report which will be disseminated online, and it will share the key outcomes and learnings from today's event. This knowledge sharing is an important part of the think tank's work to help share our knowledge and experiences beyond this room. As well, throughout the event today, we will be accepting your written questions via Slido. The link to join Slido event is on your screen now. Near the end of the event, our moderator will select some of your questions to ask our speakers. We hope that today's discussion will spark more interest in this topic and continue this discussion moving forwards. So how is today structured? So we have three parts, focusing on the circular carbon economy at the theoretical, policy and economic and technology levels. You will hear perspectives from our speakers from government, international researchers, industry and one of MI's missions. Following that, there will be a brief moderated question period, which is where the Slido comes in. So now I would like to introduce our moderator for today's event, who will introduce all of our speakers. So I am delighted to welcome Brian Efford, who is the Director of Strategic Partnerships at KAPSARC. And KAPSARC are a new partner organisation of Mission Innovation. And a huge thanks to Brian for supporting MI in many ways already, and really looking forward to furthering that collaboration. So Brian's responsibilities include planning and oversight of KAPSARC's global outreach and engagement, as well as forging multi-party collaborations and conceptualise and facilitate high-impact applied research projects in the areas of energy, economics, policy and sustainability. Brian, thank you so much. Welcome, and over to you to introduce our first speakers.
Great. Thanks so much, Eleanor, and it's a pleasure for KAPSARC and for myself personally to co-host this event and be a part of the Mission Innovation platform, think tank platform. Welcome, everyone, in the morning or in the evening or in the afternoon, depending. I'm going to try to be quick as a moderator because we've got a lot of speakers who have a lot of interesting things to say, at least I think. I'll remind the speakers, although they know this, 10 minutes, and I'll try to be reasonably aggressive at enforcing it, just because we want to get through the content and have some time for Q&A. And Eleanor did a nice job, I think, of framing the conversation and the three parts of it, so I won't repeat that. But maybe what I'll do is just move directly into the first session, part one, the concept of the circular carbon economy, with where we have two speakers. Adam Ziminski, who's the senior advisor to the Board of Trustees at KAPSARC, and Keith Quant, the mission director for MI's Integrated Biorefineries mission. We're very pleased to have both of them speak, and they'll kind of set the tone for the concept of the CCE, and I think that will then flow into kind of more practical and in the implementation of it at a technology level as we go forward. So without further ado, let me then get off the mic and pass on to Adam to kick us off with the first presentation. Thanks very much, Adam. Over to you.
Brian, thank you, and thank you, Eleanor, for that nice introduction. Could we flip to the next slide? And another one. Okay. Eleanor mentioned that the concept of the circular carbon economy builds on the idea of the circular economy, and conceptually, it is looking for a set of pathways towards net zero, but taking into account some of the difficulties associated with a kind of single-minded focus on only fossil fuels. There are a lot of people that think that the way towards net zero, or even declining emissions or the concentrations of carbon dioxide and other greenhouse gases in the atmosphere is to stop combusting fossil fuels. In the circular carbon economy framework, there are problems associated with that. First of all, it's very difficult to abate sectors like aviation, for example, and all of the others: metal smelting, heavy duty trucking, shipping, cement manufacturing, and given continuing economic growth and population growth, being able to handle the hard to abate sectors is going to be critical. There are issues of reduced access and reliability if you were to focus solely on some solutions, without taking into account others, such as renewables. Circular carbon economy doesn't have a problem with renewables. It's critical, actually, and as is energy efficiency and fuel switching, nuclear power, and so on. But what, coming back to, it's not going to be affordable to take a single pathway towards the goals of emissions reduction. The UN Sustainable Development Goal number 7 says affordable, reliable, sustainable, and modern energy for all. And so the question is, well, how can you implement that in the midst of the problems that we are having? Final thing is, there's a lot of infrastructure associated with fossil fuels. I saw an article yesterday that said that the increasing use of electricity for artificial intelligence applications is keeping coal plants open in some areas. So, again, a problem. Let's look at the next slide. Okay, I think Eleanor mentioned this as well, too. From a linear economy to a circular economy to a circular carbon economy. The key thing in the circular carbon economy is adding that fourth R. So you have reduce, you have reuse and recycle, but adding remove is very, very important. And that includes things like nature-based solutions, mineralization and storage of carbon dioxide, and direct air capture. The examples that are given here are just that. It's not a complete set, but again, conceptually, the idea is to use all available technology to allow multiple pathways towards achieving reductions and then ultimately removal of CO2 in the atmosphere. Next slide. I want to just step back a second into the end of 2019 and early 2020 when this idea first began to surface. KAPSARC went out and had discussions with a number of international organizations, the IEA, the NEA, and the OECD in Paris, the Global CCS Institute in Australia, and IRENA in Abu Dhabi. And what we wanted to do was to partner with these international organizations in areas where they had already been very active in what we saw as some of the key concepts within the reduce, reuse, recycle, and remove framework. So we worked on a guide, and the guide included energy efficiency, carbon utilization, and hydrogen chapters from the IEA, a nuclear energy chapter from the NEA, non-biomass renewables and bioenergy from IRENA, and direct air capture from the Global CCS Institute, and then a set of enabling policies from the OECD. We didn't have time that year to look at the nature-based solutions like land and forestry, mangrove restorations, coastal, ocean-based grasses and seaweed solutions that were possible, but we did that in 2022 with KAUST. The next slide, please. What I'd like to do here is to just very briefly cover some of the key areas that we think are going to be critical to implementing the framework, right? So it's great to have a framework like the CCE to enable you to think about what fits into what categories and how you can proceed in many different areas with the technologies that would lead to better management of greenhouse gases. And what we are saying here is that there's a couple of key ideas under three critical areas: technology, policy, and markets. So if you have the technology, if you have the right set of policies, and if you can implement market-based solutions, then the ability to scale up this idea into something that would actually work towards achieving the goals of the Paris Agreement, the potential for that is greatly enhanced. So under technology, the idea would be to prioritize solutions. So you look at abatement potential, cost, and maturity. You don't absolutely rely on that. You want to provide the opportunity for the technology to improve and change. But getting R&D and pilot projects going, lots of them in lots of areas all across the world, I think is critical towards advancing the technological solutions that are going to be needed. In the policy area, you need mechanisms that actually enable those technological solutions to be deployed, particularly in areas, the new areas coming up like direct air capture, which virtually everybody, not everybody, but most of the community involved in emissions management believes is going to be critical. One thing to underline is that second point under policy. This all has to be done with a very robust set of measurement, reporting, and verification systems. It's not going to be possible to get a firm movement globally without an agreement on how to measure, report, and verify how carbon is, where it's being emitted, how it's being emitted, and how the systems for managing that are working. And finally, and under markets, I think that the critical point here is that in order to scale this up, one of the things that we think is going to be absolutely necessary is advancing the idea of carbon hubs. There's likely to be a carbon hub in Houston, for example. Could be one in Rotterdam. Saudi Arabia is working on one in the industrial city of Jubail, which is north of the oil heartland in Saudi Arabia around Dhahran and Dammam. But getting carbon hubs up and running that could also include hydrogen in addition to managing carbon dioxide, I think is a way to make scalability really happen. And finally, it's ultimately going to be critical to see carbon as a valuable product that could be sold. You know, that comes back to the idea of reuse and recycle, for example. Right now, we look at carbon dioxide as a waste product. And if we could actually find a way to use carbon dioxide in things like carbon cured concrete and many in the creation of synthetic fuels and other products, it would go a long way towards making the economic side of this work. And I think my final slide just says thank you for the opportunity to present, and Brian, back to you.
Perfect timing. You hit your thank you slide just at the 10-minute mark. Thank you, Adam, both for the overview on the CCE and for starting the conversation. And just to remind folks who have joined late, if you look at the Q&A tab, we're doing the questions through an app called Slido. So if you have questions, you can start to populate them in real time, and we'll get to them ideally with some moments at the end for some Q&A. And if we don't get to your question, there's an opportunity to have them addressed in the report that will be coming out in the future. But just wanted to cover that. I won't repeat that every time we transition. I want to move on now to our second speaker. Once again, Kees Quant, Mission Director from the MI Integrated Biorefineries Mission. And just shifting gears slightly, if I could maybe oversimplify and do a little injustice to his talk, I think it's helping us walk through the importance of bioresources and biorefineries in this notion of circularity in terms of the minimization of carbon emissions. So I'm sure he'll do a better job of characterizing that than me, but please, Kees, may turn it over to you now.
Thank you very much for this kind introduction. Indeed, I feel that, let's say, we as mission integrated biorefineries fit very well in, let's say, this circular carbon economy, though we have a little bit different starting point. So next slide, please. We started actually a review that was made by the NOVA Institute looking on how can we get rid of fossil carbon in our, let's say, material system, but also in our transport system. And basically, there are three solutions. So in orange, it's the recycling of carbon. So it's really the circular carbon approach, but it's including also the fossil carbon. It can be the CO2 based. So it's the direct air capture, taking the CO2 from the air and using that to produce chemicals. Or it can be bio-based solutions. Yeah, so then we use nature to capture the CO2 from the air and use that to produce our goods. So our mission is focusing on the green part, the bio-based, so the biorefineries. And actually, in order to make a change and to make this happen in 2015, we set, well, a goal for 2030 of a 10% replacement, which is not much compared to 100%, but which is an enormous goal when you consider what has to happen. So our mission is focusing on this. So next slide. So this is our goal, to develop and demonstrate innovative solutions. So this really fits also in what, let's say, we just heard about the circular carbon economy approach. We need new solutions. We need to commercialize them, and it has to be integrated biorefineries where we look simultaneously at fuels, chemicals, and also materials. And we can replace fossil resources with bio-based resources. So this mission was launched in 2022. The next slide, please. And actually, we are working across 3 pillars. First of all, it is research and development to find more innovative ways to improve efficiency, but also to produce new chemicals out of the bioresources. So bioresources are carbon neutral. So from there you can produce new bio-based carbon neutral chemicals. But, and that's our second pillar, in order to show that this is possible, we also need pilots and demonstrations. It's innovative, it's new, and only by piloting, by demonstrations, both we can show it's possible, but also we can learn, because we learn from practice. And thirdly, and this was also mentioned already by the previous speakers, we need proper markets and policies and regulations. So it needs a good, let's say, carbon accounting to make this possible. So it's a life cycle analysis that is needed here. Well, this mission at this moment works with six members. We have with India and the Netherlands, we are the co-lead. So in India, we work with DBT, the Department of the Biotechnology. In Brazil and Canada are major core members. They are very much supportive in this action, but also the United Kingdom and the European Commission. And actually, we are open to other countries. So if you feel after this, let's say, session, this webinar, you would like to join, you're welcome to join. Next slide, please. So when we talk about markets and policies, and we talk about bioresources, the first, let's say, important action here, and it's one of our actions, it's about sustainability. So here we collaborate closely with the SEM BioFuture initiative to see how we can define sustainable biomass feedstocks. But secondly, we're also talking about life cycle analysis and carbon accounting. So we see this also as an important, let's say, aspect. And so for me, the KAPSARC approach is new to me. So up till now, we are working with the United Nations, the Life Cycle Initiative, but also, of course, with the IEA Bioenergy, different tasks we're working on this topic. And again, with the SEM BioFuture initiative. We see this is important to bring, let's say, bioresources forward. We really have to, let's say, we need a good carbon accounting. So that's why I very much appreciate this webinar where we can discuss this. Let's go to the next slide. So this is how we see the, let's say, the carbon cycle when we look at, let's say, bioresources, and it's somewhat similar to the, let's say, the slide from the previous speaker. So trees and plants, they capture the CO2. So it is stored, actually it's stored solar energy in the biomass. It takes up the bioenergy. And then, let's say, you can produce, for example, electricity and heat from it, and then it goes back into the atmosphere. So basically, this is a, let's say, a circular carbon production of electricity and heat, and that is available, is done in, let's say, a lot of different countries, but it's seen as a low value application of bioenergy because nowadays we have a lot of solar and wind that can produce electricity most often cheaper, but then let's say this route. So we're looking for new routes, the next one. And that's also where the biorefineries come in place. We have here, let's say, again, the bioresources. So it's the plants, it's the residues from crops, it's the residues from forests that are available for conversion. And they can be, through a biorefinery, they can be converted into fuels. And these fuels, they are then, again, combusted in engines. That can be in cars, but it can also be in airplanes. So it's the sustainable aviation fuel, for example. And then after this combustion, the CO2 is going back in the atmosphere as well. So this, again, it's a, let's say, a circular carbon economy. It's carbon neutral, almost carbon neutral, because we need some energy also for the biorefinery. But this is, I think, a good example of something that is happening already and can be accelerated. And that's where our mission is working on. The next slide. So we are also looking at materials. Again, we have here the biorefinery. It can produce fuels, but it can also produce chemicals and materials. In that case, at the end, we have a product. And now, let's say the circular carbon economy is getting a bit complicated, because how do we account for the carbon that we store? So basically, this is carbon storage. But when we store this in a product, for example, in plastics, it can be, let's say, a biodegradable plastic. So then the lifetime is not very long. But when you store it in, let's say, another plastic that will last for a long time, then it can be stored for a longer time. So this needs a specific accounting that needs to be developed in order to see to which extent you reduce, let's say, the CO2 and store it. Of course, you can also burn again these chemicals that you have produced, and then again it goes back into the atmosphere, and it's a closed cycle again. So these are the carbon cycles we see from the biorefinery approach, and I hope very much in this collaboration and also through this think tank we can learn more on what is needed there. So as a final slide, please, next one. We see the bio-based resources as carbon neutral. They are very important to make biorefineries, let's say, competitive. Bio-based chemicals, they can replace fossil-based chemicals. Carbon, let's say, combustion results, of course, in increased, let's say, the combustion of fossil-based materials results in increased CO2 emissions. We want to avoid that, so that's why we use bio-based materials and bioresources. And it can also result in storage of CO2. So then we talk about the CCUS. So more information is available through, for example, the IEA bioenergy on the website. You can find there a report on the Becker's carbon accounting. So thank you very much for, let's say, that this possibility to give a presentation on what is happening here. Here's my email address. So if you want to know more, please send me an email and I can inform you.
Great. Thanks very much, Kees, for that very interesting presentation. And I think it starts to show what we'll discuss a little bit more in the next part of the discussion, that there are a variety of approaches that can be taken, and probably one of the themes of the CCE kind of concept is use all tools in the global toolkit, because we don't know which will work in which context, and we want to make sure that we succeed in this very important task. With that, let me quickly transition then to the next part, and thank our first two speakers, Adam and Kees, for their contributions. But just to keep things moving, we'll have Q&A at the very end for everyone. And again, I'll point people to the Slido as a way to try to capture those. So we have 4 speakers in the next section, drawn from the Gulf, the Arabian Gulf, from Japan, and from the European Commission. We'll start with Mari Luomi, who is a fellow here at KAPSARC in climate sustainability, and she will be presenting on the Circular Carbon Economy Index. And I'll introduce the next speakers as we move forward into the next sessions for the sake of time. Mari, let me turn it over to you. Thanks.
Thank you, Brian. Good day, everybody. The million-dollar question from the previous session, obviously, is what is a circular carbon economy? So with this presentation, I'll try and bridge a little bit that conceptual and move it toward policy and implementation. The questions we set out back in 2021, when we developed this index, first was, what is actually a CCE? How do you get to a CCE? And how do you measure all this? So what I will present to you now is this composite indicator for country comparisons that we developed, which benchmarks countries against each other on 38 quantitative indicators to gauge how they're performing at present on the circular carbon economy and how well they're placed to make progress toward net zero and circular carbon economies. We can move to the next slide. Thank you. Like so many other concepts, think of sustainable development, circular economy. There are many different ways, of course, to conceptualize that, what we call the CCE. KAPSARC has played a big role in developing and operationalizing this concept in the G20 in particular. And there, during the Kingdom Saudi Arabia's presidency in 2020, there was a lot of discussion and development in this space. Adam, who himself presented, was a key mastermind in these debates. So we built on a lot of that discussion. So what is the CCE? As Adam already alluded to, it is a concept that builds on the circular economy, but it focuses on energy and emission flows instead of materials and products. It, in our view, is synonymous to reaching net zero emissions, but what matters is how you get there, which is the innovation of the CCE. The idea is, let's not pick and choose, or let's not be picky, rather, let's be holistic. Let's allow countries to choose technologies that best suit their natural circumstances, their priorities, and their development goals. And so if we turn to the next slide, we'll get the same image in a slightly bigger form. There are the 4 R's that Adam talked about. And this is how we group the main approaches, the main activities, technologies countries have at their avail to get to net zero and fully circular carbon economies. In the middle there, we see cross-cutting things such as electrification and clean hydrogen. So in a nutshell, in the index, what we do is we say, if you reach a CCE, you have reached net zero emissions in the least costly manner and playing to your country's strengths. So how do we conceptualize this? Let's, on the next slide, first look at what the index does. So it is a tool, as I mentioned, for benchmarking countries, and it's a tool for policy making. It's got 3 main aims: A, promoting the concept and its understanding. Second, which is an important one, creating metrics around this concept, and then enabling these data-driven policy discussions. We have 2 or 3 main questions at the core of the index. The first one is, how are countries doing at the moment in terms of engaging with all the main different mitigation options? And how are they doing this, not just in terms of depth, but how widely are they adopting them? Because as we well know, 1 or 2 technologies alone will not get any country to net zero. And the second main question is, how are countries today positioned? Do they have the enablers in place that will take them to net zero and CCEs? And of course, then the index enables us to compare countries to each other. So it's all relative. Next slide, please. What we do is we have this indicator framework of 38 indicators. We divide it to 2 main levels, performance and enablers. In performance, we give each country a score on 8 main technology or CC activity indicators, score from 0 to 100. And these are all based on international harmonized high-quality data sets. We do the same on the enabler side for 30 indicators, which are divided into thematic areas, including policy, technology, finance, business environments, and energy and macro system resilience. Next slide, please. What we also do is, for those countries that are large oil and gas producers in the index, we create an add-on score, which I will not talk about today, but happy to engage in conversations further or exchange thoughts afterwards, after the webinar. We add 5 more indicators that are specific to carbon circularity in the oil and gas industry. And then that gives us an add-on score that enables more meaningful comparisons, perhaps, between this particular group of countries. But let's focus on the main index. And let's, on the next slide, see what countries are included at the moment. We're now in our 3rd edition, and we are still expanding our country coverage. At the moment, we cover 90% of global emissions. All major economies from all major regions are included. Next slide, please. And let me give you a flavor of what the index can do, and when we start unpacking it, what it enables us to see. At the total index score level, which you're looking at, you'll see performance on green, enablers on blue. And this score rewards countries, obviously, that do well on both of these areas. In 2023, so this was last year, we launched this at the COP. The top 3 countries are Norway, UK, and Netherlands. And all but 3 in the top 20 are high-income countries. They represent all geographic regions except Sub-Saharan Africa and South Asia. At the bottom, we have Ethiopia, Uganda, and Tanzania. And the score between the top performer, Norway, and the bottom performer is fourfold. There's a fourfold difference. So that is a very, very significant difference, which is already one policy message, which is we're leaving countries behind in the transition, or risking of doing that. Next slide, please. What the performance score then does, it rewards countries that engage with a variety of CCE technologies. Of course, we're not expecting countries to engage with all. And that is well shown in the index, where Norway, which is the top performer, it achieves a score of 100. So it's a top country, not meaning it's there, but it is among the top performers in renewable energy, electrification, CCUS, and clean hydrogen. However, it receives a 0 in nuclear. No, naturally, it does not have nuclear energy, but still, it's there. So this gives us a flavor of what it takes to be a top performer. Again, we have a huge difference here between the top and the bottom. The top 20 list, however, is quite diverse. There's high and middle income countries from all geographic regions, again, except South Asia. And in the bottom 10, we have a quite diverse group as well of countries from all income levels, from all the way from sub-Saharan Africa through MENA to Europe and Central Asia. Next slide, please. On enablers at this level, what we can see are the 5 thematic areas that you saw on the previous slide in blue. They are policy, technology, finance, business environments, and what we call overall system resilience. These measure the factors that countries need to have in place as they to support their journey to net zero and CCEs. And there are, again, 3 European countries at the top of the enablers. 8 of the top 10 enabler countries are also at the top of the main index and CC performance. And as you see, again, there's a steep line going down, so there are big gaps between the top and the bottom performers. Now, let's dive a level deeper, and this will be my final results-related slide. On the next slide, we'll see what happens when we start unpacking and getting to the indicator level. What are we actually measuring? We're looking now at one of the dimensions under enablers, which is finance and investment. And this dimension contains 3 CC-specific indicators, mainly CC investments, ESG funding, and carbon pricing. And it measures also financial development and international financial connectedness. And this one shows very wide gaps, as you see, between the top and the bottom. Now, looking at 2 of these indicators, CC investments is an interesting one, where the 19 top countries, they're spending more than 0.5% of their GDP in CC technologies, whereas the bottom 22 spend only less than 0.1. And there's a large amount of countries that barely spend anything. A similar pattern on ESG finance, where the top 23, so about a third, are investing or raising more than 0.5% of their GDP equivalent in sustainable debt. And the bottom half of countries are again attracting less than 0.1%. So there's a huge disparity here. Carbon pricing then gives countries points on whether they have in place or in the pipeline a national or subnational ETS, carbon tax, or accrediting mechanism. And there, a total 30, so almost half of the 64 countries in the index, currently score 0 on this metric. So there's still a long way to go there. And I'll wrap up with 2 final quick slides to give you a flavor of what is out there on the index. Based on best practice, we make all our underlying data available. We have published a methodology paper, which is the yellow one over there, the first yellow one. And we've published all the annual results, of course, and analysis. And we've published and we are working on several country and regional case studies that show actually how they go into depth in looking at how does this index help interpret where countries are and whether they have what it takes to get to net zero. All of that is available via the CC Index portal and the KAPSARC website. Let me just show one more slide. We have this dedicated portal where you'll also be able to do simulations and country comparisons. And there's a lot of material out there. I really encourage you to take a look. And our team is very, very eager to receive suggestions on new indicators, for example, particularly in carbon CCU and carbon circularity. So we're out here and happy to engage in discussions. Thank you so much, Brian.
Mari, thank you very much for that. And yes, I think taking a concept and trying to measure it so that we know what progress looks like across different dimensions is going to be very important, at least from our perspective, in how do you implement the CCE. And that's a nice transition, I think. Again, I will try to keep the segues short to our next presentation, which will describe the Japanese experience with implementation of the circular carbon economy concept. And to do this, we have our speaker from the Institute of Energy Economics Japan, Yoshikazu Kobayashi-san, who's an executive analyst and a manager in the research strategy group at IEEJ. And without further ado, I will turn it over to Yoshi-san to begin his presentation. Thank you very much.
Thank you very much for your kind introduction, Brian-san. In my presentation, I will explain about how we are trying to implement the concept of CCE in the Japanese context. Next, please. First of all, I'd like to note that the concept of CCE is quite relevant in the context of Japan. We are the fifth largest energy market, but we have only limited renewable energy resources. We have relatively large fleet of nuclear power plants, but since the last big earthquake in 2011, the restart process has been quite slow. So this means that reduced side of 4R technologies of CC concept is limited. So we will reduce our emission by efficiency improvements and zero emission energies like renewable and nuclear. And we will adopt hydrogen and ammonia, but we will still have residual emissions with the adoption of those technologies. So we need reuse, recycle, and remove side of decarbonization technologies. Traditionally, the Japanese government utilized the principle of so-called 3E plus S, which is energy security, environment, economic competitiveness, plus safety. The holistic approach based on technology neutrality of CCE perfectly match this traditional principle of Japanese energy and climate policy makings. Maybe you put the next slides again. Yes, and please go to the next slide. From this slide, I will explain about carbon recycling and CCS efforts in Japan. In June last year, the government published the roadmap for carbon recycling. And according to the roadmap, we have technical potential to recycle of carbon of 100 to 200 million tons of CO2 by carbon recycling technologies. The roadmap categorizes the carbon recycling technologies into three parts: chemicals, fuels, and minerals. The roadmap assumes that minerals which does not require hydrogen to recycle carbon will be commercialized at an earlier stage around 2030. And other group of carbon recycling products like chemicals and fuels will be commercialized from around 2040. But the government is trying to advance the timing of commercialization of chemicals and fuels with hydrogen to an earlier stage by their policy efforts. Please go to the next. This is a simplified table of the technologies about the carbon recycling, which is on the roadmap. The original table is much larger. And because of the time limitation, I wouldn't go into detail, but the roadmap provides the current status, major issues, targets on 2030 and after 2040 for each carbon recycling technologies. Please go to the next. As a policy effort, the roadmap provides several policy actions. Certainly, government is supporting R&D of carbon recycling technologies. And the government also facilitate the inter-industry or cross-industry collaboration, because in implementing carbon recycling technologies, emitters and or producers our suppliers and users of carbon are often different. So somebody needs to mediate the different profile of carbon supply and demand. So the roadmap provides a mechanism to facilitate such mediations. And the roadmap also says that environmental value or the actual reduction of carbon emissions needs to be properly measured and reviewed and verified. This is particularly important when we adopt the international value chain of carbon recycling technologies, like producing carbon recycling products in other countries and import it to Japan and utilize it. We need to have a clear rule about who can claim the reduction of carbon to what extent. And also government is provide a policy to create an ecosystem of carbon recycling technology development and deployment. The government has already established a place like a campus of carbon recycling technology development. Many Japanese companies and universities had a laboratory in the campus and communicate each other to enhance their R&D activities. Please go to the next. From this slide, I will explain about CCS actions in Japan. We have a numerical target of CCS to store 120 to 240 million tons of CO2 by 2050. And in order to realize this storage target, the government aims to secure 0.6 to 1.2 million tons of CO2 storage in Japan. Please go to the next. The government has already identified 5 domestic CCS projects and 2 international CCS projects. And the feasibility studies of these projects has been already started. And combined volume of carbon storage, CO2 storage, by these 7 projects reached to 13 million tons of CO2. And all of these projects aim to start their carbon storage by 2030. Please go to the next. We have also another demonstration test of carbon dioxide shipping from one place of Japan to another. Currently, we are planning to transport CO2 from one coal-fired power plant in the middle part of Japan to the north part of Japan for the storage. And this demonstration test is scheduled to start this year. Please go to the next. As a policy actions, because CCS is new technology for Japan, we did not have a law, legislative framework for CCS operations. So we are providing a new law of CCS business activities, and probably the law will be enacted first half of this year. And as I said, government promotes feasibility studies of CCS project and transportation. And after the enaction of CCS, new law of CCS, the government will discuss about how the government can provide financial support for the CCS operators. Cost reduction and securing sufficient storage location, public acceptance will be a major challenge after the enaction of CCS law. Please go to the next. To conclude my presentation, first, the concept of CCE, perfectly match our traditional thinking of energy and climate policy makings. Second, I noted categorization of 4 R's of CCE technology is a little bit different from that of KAPSARC, but bottom line is same. We need reuse, recycle, and remove of carbon to realize carbon neutrality. And particularly carbon recycling and CCS will be two major areas for Japan to implement the CCE in our climate actions. I'd like to stop here and thank you for your attention.
Thank you very much, Yoshi-san, for a very interesting presentation. It's fascinating, or at least for me, to hear of the way Japan is implementing this notion of circularity and carbon reductions, and hopefully a set of lessons learned that we can derive as a group in time going forward. We turn next to our next speaker, Joanna Fickstall. I hope I didn't butcher it too badly. Joanna is the Policy Officer and Director of the Directorate General on Energy in the European Commission. And Joanna, I think we need to give, if you have slides, I think we need to give you control in order to present the slides. Is that correct?
So thanks a lot, Brian. I don't think I will need any slides. We'll just take it orally if that's okay for you.
Perfect. Yes, thank you very much.
Okay, so thanks a lot for inviting me, first of all, and for giving me the floor. So yes, my name is Johanna Fickstall. I work as a policy officer in DG Ener in European Commission. I work in the CCUS team there, and right now we are finalizing the strategy on industrial carbon management, which is like rebranding, I guess, the old CCS acronym, because now we call it ICM, or Industrial Carbon Management, to say that we want to cover both CCS from fossil sources, industrial sectors, and industrial carbon removal, so directly from the atmosphere, as well as CCU, so carbon utilization using CO2 as a valuable resource. And this strategy will be published on the 6th of February, so we are in the final countdown now, so keep posted. But I wanted to take this opportunity today to also highlight what we are doing more specifically in this strategy, because really it's about building not only the regulatory framework, but also a CO2 market more or less from scratch, which is very interesting. But we have tried it before, and we can admit that we failed a bit. So we want to make sure we are doing it the right way this time. But we see that there is a need for the EU to coordinate this market on an EU level to make sure that we have harmonization and standardization so that CO2 can flow freely across Europe. And in this context, we are trying to see how we can connect the dots through infrastructure, so connecting the emitters in Europe with storage providers, and to use the transport infrastructure as a key enabler to bind these value chains together. Soon you will hear from my colleague Drasen in JRC. They are now finalizing a study that he will explain to you a bit more in detail. But just to say that this will be a very important tool for us in order to ensure network planning, because like I said, we don't know yet how the infrastructure and market will develop because we're building it from scratch. But we want to make sure we are doing it in an efficient and cost-optimized way, so that now we see that we have some mature projects, especially in the North Sea, on CO2 storage. But on an EU level, we want to make sure that all parts of Europe can be connected to the infrastructure so that they will have closer connections and not having to ship their CO2 all across Europe. So in the study by JRC, they have different scenarios, and I think it's interesting to have a basis of discussion to understand how the infrastructure might develop, but also gradually when we start to have projects being operational, we can put this in the map and we can try to plan the infrastructure accordingly to see what makes sense. So network planning, and also to make sure we think about the integration with other infrastructure like natural gas and hydrogen will be very important. And as I said, we don't have a dedicated regulatory framework yet. So we need to think about ensuring the rules for this market. For example, third-party access, ownership structure, and models. These are some of the topics that we will need to assess further. To conclude, I think I can say that yeah, we are finalizing this strategy now, but this is only the beginning, and we have a lot of action points that we are considering, and also that we will announce on the 6th of February. And this will be I guess the start, and then we need to implement it. So yeah, please feel free to contact me if you have inputs. We already have a lot of dialogue with industry stakeholders, because in the end we are doing this for the industry to scale up the market. And it's a nascent market, so we still need a lot of financial support to deploy these technologies. But I think it's a good momentum now that we are seeing in Europe on industrial carbon management. So I look forward to discussing this with you going forward, and also to publish both the strategy and the study by GRC. So thanks a lot, Brian. Back to you.
Thank you so much, Johanna. Yeah, it's fascinating to see the progress in such an early stage market that the developing countries in the European Commission and Japan are making. And some of that, maybe we'll get to this in the Q&A about this concept of the energy trilemma and climate justice, and what the developing world can do and how they can benefit from that. But that's maybe out of the scope of this presentation, so I'll defer that for the moment. We'll turn next to our second speaker from the European Commission. To kind of extend on the conversation, I think, let me introduce Drazen Tumora, who's a project officer at the Joint Research Center, also at the European Commission. He'll give a talk on the transport network and how that's shaping up for Europe. Drazen, over to you.
Hi, Brian. Thanks for the introduction to you and to Johanna. I have slight problems with connection, so I apologize if something happens during the presentation. So I'm working at the GRC. For people who are not familiar with the GRC, it's a Joint Research Center. It is a part of the European Commission, and we provide independent, evidence-based knowledge and science, supporting EU policies to positively impact society. And this presentation is about our successful collaboration with Johanna's team from DG Ener. Please, next slide. The study and analysis we were working together is related to CO2 transport network for Europe, as Johanna already said. Basically, this is an update of the modeling, which was initially done more than 10 years ago, when the first attempt to develop CO2 market was unsuccessful, but now we hope it will end up better. The idea is to create the transport infrastructure which will span across the Europe, and basically it's a matching of CO2 sources and CO2 sinks or storages in a cost-optimized way. The time horizon of our analysis is 2050, with snapshots for the years 2030 and 2040. It covers all EU member states, and Norway and the UK were included in the analysis only with respect to storage sites due to their relative importance for EU. And the study focuses on CO2 transport by onshore and offshore pipelines and suitable maritime ships. The transport infrastructure, we believe, will play a major role in the European CO2 transport network. Next, please. Here you can see the simplified overview of the methodology. It consists of 4 key steps. So first step was to identify and cluster the CO2 sources and sinks to create nodes. Then the second step was to create routes of potential connections between nodes. Then we created, in third step, scenarios based on assumption about the evolution of captured CO2 emissions and about the assumptions related to storage capacities. And the final step was the cost-optimized CO2 network. And the main condition was that CO2 captured at any given point in time must be stored at that point in time. Next. But before I go to the results, I would like to say a couple of sentences related to key issues we faced during the analysis. So first, and I think the most important, is storage data availability. Assessment of storage potential in EU was done before, but the problem was it wasn't the whole Europe wasn't covered, and there are a lot of knowledge gaps. For example, for some locations, we know there is storage potential. We don't know the let's say exact number, and the potential that was estimated could really differ with the real capacity, but that we can only know after we start with the developing of the location. Other problems we faced are inconsistent and outdated CCS project databases. The problem was we wanted to merge data on announced projects and data related to different projections of CO2 capture and CO2 storage capacity. Then what was really important for our study is to have spatial data, and often that wasn't the case. We could get information on project, but the spatial data was missing. Also, project developers are, because of the uncertainties, they change their plans. They have different options, and they still don't know what will be their main, let's say, plan or target. And also, when we, let's say, overcame all these problems, there is always a problem with the implementation of projects, because CC early adopters, they face a lot of problems, and sometimes they completely change the plans. They switch to something else, to, let's say, hydrogen. They decide not to pursue the CCS path. Next, please. Here you can see the results of the modeling, but this is just for one scenario. We covered 8 different scenarios. We tried to investigate what will happen under different assumptions. For example, what if we can store EU captured in CO2 captured in European Union? What happens if we can store it just in EU? Then what happens if we can store it in Norway or UK? Then there is a public is not accepting, let's say like that, accepting the storage onshore. So what will happen if we can store it only offshore? And here these maps and our report basically illustrate the potential extent of the network if the capture and storage capacities are matched in an optimized way. And the results showed that the network could reach a length of up to 19,000 kilometers in 2050, and the investment costs could reach 16 and up to 23.1 billion euro if we include the all, range of cost estimate. Also in 2050 in EU, around 250 megatons per year could be captured, transported and stored. And between the 2025 and 2050, around 3.9 gigatons of CO2 could be stored. Based on our analysis, CO2 will be captured in 21 countries and stored in 17 countries. And there are 29 cross-border points which connect 23 different countries with the CO2 transport network. Please, next. But the development of European CO2 pipeline infrastructure will be challenging during the early phase of the CCS deployment before 2030. And alternative forms of CO2 transport should be also explored based on the announced CO2 transport projects. It is realistic to expect that a significant part of the transport will take place through alternative forms of transportations, for example, via rails, roads, or rivers. CO2 will be transported to the coast and then transported further by shipping to offshore storage locations, which make up the majority of the storage capacity. And in addition to shorter lead times compared to pipelines construction, shipping offers flexibility, which could be crucial for CO2 transport in the early phase of the CO2 transport network development in EU. And after 2030, or with further development of the CO2 market, there could be significant progress in CO2 transport by pipelines. Next, please. This is my last slide with the conclusion. So like I said, the network could reach a length of 19,000 kilometers, and its deployment could be quite costly. And our main findings are that early CCS adopters have a significant impact on the evolution because the network evolves around them. There could be a lack of commercially proven storage capacity in the early phase of the network development. That's why we need updated CO2 storage atlas. And because of the highly international character of the network, we need CO2 quality standards for transport and storage. And our main points that CO2 transport is a key enabler of the deployment of CCS in Europe, and international coordination and collaboration is crucial if you want a successful and cost-optimized development of CO2 transport infrastructure. That's all. Thank you very much.
Thank you very much. I appreciate the interesting talk. We're starting to run short on times, but we have two final presentations on the kind of technologies, present and future, that are needed to actually, or that can be used to actualize the CCE. And we have two speakers here. And I have to give a special thanks to Suhas Dixit, the CEO of AP Chemi. Suhas was to give credit where credit's due, responsible for the idea for this webinar on the circular carbon economy. And so we're very thankful for that suggestion, and the think tank took this up. And really because of the time limitation, but we will run a little bit past our stop time. So I mean, don't take it too liberally, but we want to allow some time for Q&A. And I think Suhas, we wanted to give you control of the slides to make it a little more convenient, but we still want to try to keep it to 10 minutes if we can. Thank you so much.
Yeah, thanks, Brian. I think my screen is visible now.
Perfect.
Okay. So let's dive right into it. So this presentation is focused on biochar and advanced recycling, contributing towards circular carbon economy. So as far as circular carbon economy is considered, there are several technologies which are at either mature stage or early adoption or demonstration or prototype stage. As AP Chemi as a company, we are focused on biochar-based carbon sequestration and circular carbon economy for plastic via chemical or advanced recycling or plastic or tire. So my presentation will be based on these 2 points, biochar as well as chemical recycling. These are some of the visuals of the work that we've done. We are leaders in pyrolysis. We turn non-recyclable plastic, tire, biomass waste into value. We've developed 47 projects till date since 2007, transformed 179 million kilograms of plastic, over 1.3 million hours of technology performance. We are supported by Shell E4. Recently, we raised funds in collaboration with Aalborg University to convert plastic and biomass into hydrogen. We are working on large-scale pyrolysis projects to process plastic, tire, and biomass across the world. We've created over 3,000 jobs since 2007. We have 12 patents, out of which 5 are granted. So first part of the presentation would be making biochar and enriching the soil. The key advantage of biochar-based carbon capture and sequestration is that you don't have a storage problem and you don't need logistics for for carbon sequestration and all. You can just put it directly into the soil. So here our experience is that we can produce quality biochar. Of course, there are a lot of players in this market. What we've done is that we've licensed technologies. We have supplied biomass pyrolysis plants. We have ability of producing very high quality biochar that can be stable for 50 or 100 years as per global biochar standards, as well as European Biochar Association standards. We have 50 ton per day continuous type bamboo pyrolysis technology operational in Northeast. And in another technology, we've also converted certain post-industrial biomasses like soap stock, waxes, tallow into high quality biofuel and biochar. So this is as far as the circular economy focused on biochar and sequestering the carbon is considered. The next part of the presentation is converting plastic back into the plastic so that carbon kind of remains in the loop rather than going to the environment. So less than 10% of carbon that is inside plastic is recycled. Rest all goes to landfills or incineration, burning, river and ocean. We don't understand how much is the carbon footprint of plastic waste. It goes for incineration, and every year it generates 300 million metric tons per annum of carbon dioxide emissions. From now to 2030, burning of plastic waste in waste to energy and incineration plant will add 1.2 billion tons of, 3.5 billion tons of carbon dioxide to the environment. And another dimension of the problem is that around 400 million metric tons per annum of crude oil is pumped every year to make new plastic. So when it comes to plastics, it's very much a linear economy of carbon. Even if there was some effort to put plastic into the roads, but the problem with putting plastic into the road is that if you when the road dust comes out, all the microplastics come out. So you cannot directly incorporate plastic into the roads. As far as chemical recycling is considered, this is the problem statement that crude oil is used for production of polymers, which are used by FMCGs. Plastic waste then goes for landfilling or incineration. Even if you convert plastic into oil, this oil has a lot of corrosives and catalyst poisons. That's why this cannot be used as a fuel. And this oil, impure oil, cannot be used for production of any products or circular plastics and all. The way we solve this problem as a company is that we convert plastic waste into purified oil. We also convert plastic into bitumen. Even if somebody else produces impure oil, we can purify it, and then this purified oil can be used ideally for production of circular plastics. And this also can be used as a feedstock for production of hydrogen, diesel, sustainable aviation fuel, and all. So reaching the purified oil that can be used in the existing petrochemical asset is the effort that we are focused on. Another dimension is what is the carbon footprint of managing plastic waste. So if you see incineration, and sometimes there are landfill fires as well, especially in the developing countries, it's a very common sight to see landfill fires being there. And in case of landfill fire, not only CO2 comes out, but also methane comes out. So the emissions in terms of carbon, CO2 emissions per ton of plastic getting burned in the landfills is much higher than just incineration. But when you compare it with chemical recycling, your emissions can come down almost 30, 40, 50 or 60%, depending on to what extent the polymer production happens out of chemical recycling. We as a technology provider are able to reduce the use of chemicals in chemical recycling of plastic waste. So we have an advantage of getting the plastics chemically recycled at around 20 to 30% lesser carbon footprint than conventional way of chemically recycling the plastic. So Brian, I'm done here. So I'll stop sharing and we can proceed with the next speaker. Yeah.
Suhas, thanks so much for that. And it's, for me as a non-technologist, it's fascinating to see what technology is making possible in this notion of circularity and recycling of these kinds of products. So thank you for sharing some of that insight, especially for folks like me. And now we turn to our final speaker, last but certainly not least. Let me please introduce Erica Bosson, a low carbon consultant at Worley Consulting, and she'll cover another perspective on kind of the technologies that might be useful in the utilization of CO2 and the CCE perspective. Over to you, Erica.
Thanks, Brian, and thank you for inviting me to speak today. It's very exciting to speak to such a wide audience. I am the last speaker, and I know we've had an array of absolutely fantastic speakers ahead of me. So I'm going to do a very high-level overview of some of the CO2 technologies that have been spoken about earlier that fit into the CCE concept. I'm going to focus, I know we've done a little bit of talks on fuels, on polymers, so I'm really going to focus on the technologies of the future. Where are we seeing some investment being made, some advancements being made, and where could this economy take us? So can I have the next slide, please? We've spoken a lot about the supply chain. I think right from the beginning of this conversation, we've looked at how CO2 can be utilized. So that box on the right there gives you a very high-level overview of what the direct uses and the conversion uses are. And I think as Adam was talking about and as Marie was talking about, this is really telling you where the reuse and the recycle potential is for the CO2. And I think Suhas's technology fits really well into this box because they're looking at the conversion use potential of the CO2. So another suite of technologies inside that box. Can I have the next slide, please? Thank you. So I'm going to do a very quick overview of where these technologies currently stand. So TRL or CRI, for those who might not be aware, is the technology readiness level and the commercial readiness index. Now, these are two indicators. They're not scientific values. They're merely indicators that tell you how ready a technology is with its market appearance. So a TRL of 9 being the highest means the technology is currently being used in commercial perspectives and it is commercially a profitable technology. Lower technology readiness level and commercial readiness indexes, 1 to 2 to 3, these are when they're in their pilot phase, going to pilot scales, and then progressing across the scale when they approach commercial usage. So EOR, I think, very well-established technologies. I'm going to focus mainly on the upcoming ones, the ones with the lower TRLs. But just to provide you an overview, EOR, very, very big in the Middle East, as we mentioned earlier, and in the US, for example. Food and beverages, I think I've seen some questions come in. Now, food and beverages is a very interesting application because it's one of those applications that has a huge market. It is something that the TRLs are high. We know how to make carbonated drinks. We know what the technology is, but it requires very high purity because it is for consumption. So when the capture piece is able to provide us with that high purity that's required for the food and beverages, or the biogenic capture piece is there, that's when the food and beverage industry will really see a boom in as a reuse potential for CO2. The Netherlands, moving on to horticulture and greenhouse gases, the Netherlands is a huge player here. They're pioneering this technology to use the CO2 in their greenhouses. And then moving on to I think I saw supercritical CO2 on some of the earlier slides. Maybe Adam, you mentioned it's an upcoming technology. As an industry, we're very familiar with supercritical CO2, but what we're not familiar with is how it transports. And really, when you're talking about supercritical CO2, you're talking about CO2 in its dense phase. You're talking about it in a phase where it has liquid-like properties, so you can very easily transport it through pipelines. That piece there, the getting it up to supercritical temperatures and pressures is not really the roadblock. The roadblock here is getting the pipelines in place. And I know the European Commission just earlier spoke about the technological advancements that are going on and the research that's going on into this. Later on, I'll dive a little bit into heat removal systems using CO2 as an upcoming technology and a potential reuse case that we are seeing gain a lot of attraction. Next slide, please. Thank you. Now, these are your conversion opportunities, and you'll see some things that have already been talked about. You'll see some overlaps, but this is really where you're looking to recycle or remove carbon. And when we talk about the CCE, reuse, recycle, remove, these are the latter two opportunities. There's opportunities to convert CO2 back to fuel. There's opportunities to make them chemicals, urea, methanol as a chemical. Polymer, as Suhas just spoke about, trying to get them back into the plastic format with chemical recycling. And then another interesting piece, and a piece where we're seeing a lot of development, is the building block aspect of this. And it's very interesting because building blocks and the other applications as such almost become a carbon sink, because from this technology, you're going to sequester almost your carbon into things like bricks, into cement, into equipment that is used in industries today where it is not combusted. So that CO2 then isn't just delayed in combustion. In fact, it is sequestered or stored in a formation. And finally, there are some other applications that are upcoming, such as surfactants, cleaning products, pharmaceuticals, and medical applications. But really, what's important to notice here is that the purity of the CO2 that you get plays a very important role, in addition to what type of CO2 you need. If the CO2 release is being delayed, it has to be biogenic CO2. But if it's being sequestered, it can be captured CO2 according to some legislations in some parts of the world. It's a very high level overview. I'm not going to get into much detail, but if there is anything that is of interest, I'll be more than happy to have a chat. Just to round off my presentation, I wanted to highlight a few of the upcoming technologies. The segment is all about technologies of the future. So if I could move on to the next slide, please. I'm really looking to highlight some of the newer technologies that we're seeing gain traction, as I've spoken about this earlier, but supercritical CO2, CO2 as building blocks, and CO2 as surfactants or regular cleaning products. These are technologies in very low TRLs right now and very low CRIs. They're not very commonplace technologies yet, but we're seeing some investment and some progress being made. So if I could just get to my final slide. So supercritical CO2 for heat recovery, this opportunity, you're really harnessing the fantastic properties of supercritical CO2, where you're able to, in a very efficient way, use it as a heat removal medium in multiple power sources, in multiple sources where you need a heat sink. So far, there's some great research happening in Germany to progress this this concept, and we're really waiting to see how far technology is taken in this area. Another industry, again, is carbonates and surfactants. Now, I think it's also very important to mention, as I believe Marie did earlier, we're not being nitpicky with our utilization options here. There isn't a silver bullet that's going to work for all the CO2 that needs to be used, that needs to be part of the CCE to help us reach net zero. It's really a suite of applications. So you see here, there's a wide variety. You can use CO2 in building and construction, which is a booming industry. We know this isn't an industry that we see declining, or you can use it, for example, in, as I've highlighted here, in cleaning products or the medical industry. It's important to, I think it's very important to remember that there is going to be a suite of technologies, and there isn't one silver bullet technology that's going to fix the CCE or support the CCE. So closing out, the final two technologies here, CO2 to carbonates, storing them into, or mineralizing them or storing them into building blocks, which is a booming industry, has a huge potential. And finally, CO2 into surfactants, or cleaning with CO2, as Covestro puts it. Another upcoming technology looking to introduce and integrate captured or biogenic CO2 back into our daily lives, and in the meantime, then you are displacing crude-based, whether it be ethylene oxide or other chemicals. So just to note, this is not an exhaustive list. It's just a few that we have picked out, but due to time, keeping time in mind, and I'm sure Brian is kicking me under the table here, I will say thank you. Thank you so much for giving me this opportunity, and we look forward to the Q&A.
Erica, thank you so much. I'm thrilled, and yeah, you even saved us 30 seconds, so well done. And that leaves us a little extra time for Q&A. We will have more than 2 minutes for folks, although if you have to leave, please do, and we can try to engage later. But we do have a few questions, and you'll notice the link here for Slido. This is where the questions are coming in, and you have the opportunity to vote for a question you like if you want it asked. And we're going to start with one that's been upvoted. Not in great quantity, but I think it's a good one to head right into. And maybe what I'll do is I will pose it to the group, and then I will pick on someone if I don't get an immediate response, since we're so short on time. Because so the first question maybe to get to is the issue of locking in greenhouse gas emitting practices like combustion engines. And the question is, can the CCE, is there some risk that it will lead to lock-in of these kinds of technologies, these emitting technologies that are less efficient and slow down, in effect, the net zero transformation? So do we have anyone who wants to take that question? There could be a couple different ways to address it. Otherwise, I will pick on someone to take it on. I think Keys and Adam are giving the two I had in mind, so I'll let you start, Keys, and then Adam.
Okay, so thank you very much. Yes, indeed, I think this is very crucial. We have to, when we look at, let's say, the circular carbon economy, and if we see CO2 as, let's say, also as a resource, yes, then we have to, let's say, valorize it as much as possible. And so there are a lot of different applications for let's say CO2. So when we run it through direct air capture, we can produce a lot of different chemicals, but of course it's still expensive. We can also do it through the bioresources, which are available in many locations at this moment as residues. We can use it, but even then we have to look at, let's say, creating the highest value out of these products. And indeed, I agree that then where we have, let's say, alternatives like solar and wind for electrons, maybe it's not always the best way to use, let's say, the bioresources there. But there's also a lot of locations around the world where it fits well into the system. So you just have to see what is necessary. And then indeed, where we have areas where we cannot electrify, like fuels for transport sector, like sustainable aviation fuels, or for chemicals, there we see a huge market for, let's say, using the CO2 through the bioresources to produce these chemicals and replace the fossil resources. My reaction. Thank you.
Thanks, Keys. Adam, do you want to take a slice at the same question?
No, I think Keith did a great job at that. What I wanted to mention, Brian, was in many ways a taxonomy of this: reduce, reuse, recycle, and remove. I don't think we should get too hung up on exactly where each of these technologies fits within that framework. Hydrogen, for example, can go across to all four. There are some issues within recycle and reuse that different organizations classify the opportunities in different ways. And I think that what's really critical is making sure that the policies are designed to enable these technologies to be able to be scaled up, as soon as possible. We've got to make progress on dealing with emissions, and in many ways, what that means is just getting on with it, rather than worrying too much about the academic issues associated with exactly how to classify each of the things. Ultimately, it becomes important in terms of measurement, reporting, and verification, and some of the issues that Mari talked about in terms of how the CCE index is set up, I think highlight that. Back to you.
Great, thanks for that. And actually, I think embedded in that question, at least from my perspective, is a notion of cost, that new technologies, especially emerging technologies, are expensive. And one mode that lock-in may happen, or prevention of use of quote unquote better technologies from an emissions perspective, might be their cost. And that kind of feeds into the next question that we got upvoted and maybe Mari's, this is on the CCE index, so maybe I'll give you give you a crack at answering. But the question is that many of the countries at the bottom of the CCE index are also the most vulnerable to climate change. And of course, the reason they're there is because they probably can't afford these technologies in many cases. And the phrase I throw around sometimes that I hear in the global south is sometimes maybe you have to carbonize before you decarbonize. So there's technologies that are inexpensive that you can use to grow your economy. And so how do we help enable those countries to use maybe more expensive but less emitting technologies? But the question really is focused on whether some control for emissions, making an emissions relative index, might improve as an indicator. So there's a couple different factors, I think, in there, and I'll take it from where you want to. Over to you, Mari.
Sure, thank you, Brian. I'll just make a few very brief observations to this question. Indeed, I think there's a bit of unpacking there that one needs to do. Yes, indeed, it's usually the low-income countries that have the lowest GDP and the lowest per capita emissions that also happen to be the most vulnerable to climate change. And that's an unfortunate fact of life. And our index obviously reflects this fact. And as Brian was just saying, these are the countries that are not generally doing well on most development metrics. And that's just how indices are. There are some bright spots there when you go to the indicator level, look at different countries. And we do have one indicator in the final part on system resilience, where we look at climate risk. And there actually we can see that it's not just the poorest countries that are prone to climate risk. They're just the least capable of being resilient vis-a-vis that. So yes, there's a lot that we could do. We could compare the index results with climate vulnerability. That's a nice idea. Second point, it is often these poor countries that also in many cases have access to or the ability to develop nature-based solutions. So that is one way where carbon markets, for example, some view this critically, obviously, but have some potential in also bringing revenue for these countries if they expand on that part of the CCE. And then finally, why not emission-based metrics? This was actually a starting point in developing the index. You can go and look at emission statistics and data, and there's great data portals out there that enable you to do comparisons like the Climate Watch, for example. And so we didn't want to do that. We wanted to create something that speaks the language of technologies and pathways and is somehow an addition to this discussion. And that's how sometimes our results can be a bit counterintuitive, but they're intended to be the start of policy discussion. So hopefully we'll hear from you on that. Thanks.
Yoshi-san, I saw your hand go up. If that means you want to answer, please go forward.
Yes, thank you very much. Yes. I just like to note that in this session, we tend to focus on reuse, recycle, and remove. But what is great in the concept of CCE is that is not reject, reduce. So everybody knows that reduce is quite important, but we are talking about reuse, recycle, remove because reduce is not sufficient to reach the carbon neutrality. That is one thing. And another thing is about the cost is, I think this is a classical chicken and egg problem. But my view is we need to move to develop an infrastructure. Once we have an infrastructure, we will have more productions, and we can expect the scale of economies. Of course, we need to closely evaluate the relative economics, either this technology is better or not. But I think development of infrastructure is quite important to reduce the overall cost. Thank you.
Yoshi-san, thank you for that answer. And I would love selfishly to continue for the next hour, but I fear that we might lose all of our participants if we go that far. What I will do though is we have one more question that was upvoted, and maybe we'll make this the last question. And it has to do with real estate and real estate, you know, whether it's development or other forms of real estate, commercial, private. How can it make contributions towards implementing the CCE framework? I've got some thoughts, but if there are other folks on, the expert panel, please maybe give a first crack at it. Erica, maybe turn over to you.
Yeah, thanks, Brian. I think that's a really interesting question, actually, and very honest. So thank you for that question. I think there's a lot that can be done in the real estate industry. We started off with this whole conversation of having building blocks. So when you come down to real construction, there is a lot of reuse potential for CO2 there. But diverting from that, if you're not really a contractor, but looking at more just real estate, there's a lot of energy efficiency opportunities. And I think it's just mentioned that the CCE also includes reduce. So when it comes to energy efficiency, when it comes to smart buildings, when it comes to having heat sensors in places that can allow you moderate temperatures and integrating your infrastructure or your assets to be energy efficient, that the impact that has on the CCE, I don't think should be undermined. And I think we're seeing some development in it, especially in the Middle East. We're seeing a lot of development in the smart building concept, which is something that can hopefully very easily translate into the real estate business. Thank you.
Great. No, thank you very much. And my connection dropped, of course, during your answer, but I'm sure it was thank you for providing it. And maybe just the last thought I'd given, and I hope I'm not duplicating your answer, but I mean, I think there's a difference if it's a greenfield project, real estate development project versus retrofitting or taking a current and existing project. And so for greenfield, I just giving it a local example, in the Kingdom of Saudi Arabia, the Red Sea Development Corporation is taking an austere, a pristine environment that's been essentially untouched by development. And I guess the lesson learned that at least I take as a non-developer from that is that if you plan from the beginning on the principles of the CCE and on preservation and sustainability, that goes a long way towards, and then you implement and build around that plan and stick to it, again with measurement and verification, then that's perhaps a way to try to implement the CCE framework from a greenfield development. It might be much harder if you have to retrofit a building that is not efficient or a community that maybe has some problems. But there may be technologies out there that we can utilize. I think we're now at 10, 11 minutes past the drop dead point on the session. And so I guess we should wrap it up there, although I'd love to keep going. One of the questions was that we got answered was whether the slides would be available, and the answer to that one is yes, along with the report that will be posted on the Mission Innovation website when that comes out. You also, either through the invitation or otherwise, have the contact information of my two colleagues, Ingrida and Patrick from Mission Innovation, and also mine. So if you have questions that didn't get answered or addressed, and I'm sorry we couldn't answer all of them, there's some good ones there. Feel free to try to reach out and we can try to connect you up. We'll also try to address those in the report that's released in the near future on the Mission Innovation website. So with that, I should conclude and say thank you to all of our participants who've stuck with us through the full session. Thank you also very much to our speakers. It's a privilege to have extending from North America to Tokyo across the time zones, such a robust set of speakers. And very much appreciate all the insights you were able to share with us. And I hope the audience found this as useful and as interesting as I did. Thank you very much. I hope you have a good rest of your day, mornings, evenings, wherever you happen to be. Take care.